on that and following Tapelo's questions, or the questions to Tapelo, my area of expertise is really copyright. I'm not a patent attorney, so slowly on the technical stuff. Thank you for coming out to this session. I know we're up against some really good topics in the other rooms as well, so I appreciate you being here. As you know, the topic today is rapid prototyping and what I like to call its IP conundrum. I've done some research into this technology and I found it fascinating. I found where it has gotten to absolutely fascinating. I did not expect to find the kind of information that I have in terms of what is being done with this technology, where it is being applied, by whom, who's engaging with it. And in so doing, I've just realized that there are a whole host of questions that start arising in the socio-economic space and the socio-legal space. And so that's what I'm going to touch on today. So what is this technology that we're talking about? The rapid prototyping technology. It's also referred to as additive manufacturing or simply 3D printing. Those are all terms used to describe the same process. And what it is, it's simply an alternative manufacturing process, meaning manufacturing done in a different way. The technology behind it is technical and it is complicated, but the process itself is really very simple. Step one, you just need a 3D digital design, a model. Step two, that's typically a CAD file. Step two, it goes through what we call a slicing process. What that does is it really adds onto the CAD file a set of instructions that tells the printer how to layer by layer create the 3D model. It tells it where to put the material, at what speed, the temperature, that kind of thing. So a set of instructions that tells the computer and the printer what to do. Step three, printing happens and you have your three-dimensional object. You can equate it to a printer, and the printer, you put ink inside, it has a nozzle, and according to how it's been told to print, it will layer down the ink. 3D printer, exactly the same thing, only difference. It can build those layers up to a three-dimensional product, and you can put any material inside it. It gets very interesting here because they are printing currently in plastics, resins, concrete, any kind of metal, jewelry being printed, sugar, chocolate, foodstuffs. All going into the printers, layer by layer, building 3D objects. It's amazing. So it all sounds very futuristic when you put it like that, but the future is now. It's current. It's being applied very, very widely. All of the major industries are using this type of technology. The major industry players are all using it. BMW has just built a 6,000 square additive manufacturing facility just outside of Munich, and that should tell you the extent to which they have engaged with this technology and are using it already. But quite apart from the big players, there is an entire movement attached to this technology that operates exclusively in the DIY field. There are hundreds of thousands, in fact millions, of consumers with desktop printers or they have access to desktop printers who are creating, they are sharing designs online on a global scale. They are not only printing, but they are building printers and very freely sharing information. And that's all happening right now as we speak. There's an online design repository where you can find 3D printable files of just about anything that has over 1 million users. And there are more than one of these examples all across. We even have some local ones in South Africa. So it is a very relevant, very current, it's happening type of technology. In uncovering all of this information that I have as to where the technology is being applied, the extent to which it is being applied, and what it can do, I realized that there is a balance required. The balance required will be between, on the one hand, this technology really holds unprecedented socioeconomic benefits. What it can do will take any economy forward. On the other hand, it really enables uncontrolled proliferation of infringement. It is practically uncontrollable unless we find ways to control it. And therein lies this question, this conundrum. So we need to find a way to enable the support for this technology. We need to find a way to enable the development of the technology, but at the same time, we need to find a way to make sure that rights holders are protected, that there are proper mechanisms in place that enables enforcement of rights in a practical way. And is all of the legislation really on par and able to do that, or do we need some adjustments? So in thinking about that balance, starting with this socioeconomic benefits, the type of benefits that they are seeing with this technology is first and foremost reduced R&D window and costs. So the alternative name, rapid prototyping, says it all. It really is rapid prototyping. You can print on site. You can test the product right then and there. You can see what is needed. You can make adjustments simply by going to the computer and adjusting the 3D CAD file. Print again, test again. You don't have to wait weeks for the prototype to be returned before you can proceed. So you can, in an easier, quicker fashion, you can get to a better quality product, and it also enables earlier entry to market. Anything, of course, that saves time, saves costs, that's a major benefit, all of the cost saving. But with it also comes reduced operational risks. Here, if you think about the traditional manufacturing process, there are several steps between CAD design and end product. You've got cutting, building, welding, coating, drilling, all those steps involved before you get to installation. In the 3D printing process, you have your design file, printing, installation. By cutting out all of those steps, you cut out all of the risks that go with them, and of course the costs. But in addition to this, it also, because of the way the technology works, layer by layer, and you can determine where you need the material to be put down, it enables precision, which reduces risk. It also enables a lot of design freedom and customization. The customization is quite a major benefit of this technology. Just to give you a simple example, is in the United States of America, the NFL is using this technology together with 3D scanning technology to scan football players' heads and then produce their helmets according to their exact requirements, thereby reducing brain injuries. So we've got all of that. In addition, the technology is, in its own way, assisting us in solving the planet's problems and can do so even more going forward. Because, again, how the technology works, layer by layer manufacturing, you've got a major reduction in waste. So traditional manufacturing process, subtractive manufacturing, you would have to take away, if you have a block, you have to take away material, you've got a lot of waste. You don't have that problem with this technology. But in addition to that, because it's so versatile in terms of the materials that you can use, they are printing with foodstuffs. There's a restaurant that opened in London in 2016 that only uses 3D printing to produce their meals. But more than that, they 3D printed anything and everything inside the restaurant too. The furniture, everything. Lighting fixtures, it was all printed. But getting back to the foodstuffs, we can print food. Thinking about disaster relief, you can put on a 3D printer that can print whatever is required, whether it be food or whether it be tools. In addition to that, they're printing houses. In China, they've got machines that can print 400 square structures in less than 24 hours at a very, very reduced costing. So, looking at housing problems. So that's why I said that the socio-economic benefits of this technology is unprecedented. It's mind-blowing. And therefore, it is something, in the fourth industrial revolution, any economy that wants to be relevant there cannot ignore this technology. We have to enable ourselves to participate, to develop, to support not only the technology, but all of the role players that want to participate in the technology. But we need to consider all of the threats. So looking first at the economic impact, immediately what comes to mind is job losses. That's there. But they expect or predict global trade and exports to reduce by between 25 and 50% over the next 40 years. 40 years is not that long. mainly due to two reasons. The one is that manufacturing will happen in-house. I mean, BMW is a very good example. But largely because consumers will become manufacturers. It's called the prosumer, the producing consumer. If you have a printer, you can get a design file, you can print at home. You're going to print your parts at home. I was playing around on some of these online design repositories. Think it and you can get it. If it's plastic and it moves and it goes into a BMW, you can get a design file and you can print it. So there's that impact. The other one is that they expect this technology on the very high end and the complicated parts. The technology and the printers are still expensive, but with all technologies, it is shifting. So they are expecting the technology to become cheaper than even the cheapest labor markets very soon. Of course, most of those labor markets are in Africa. What happens? Those manufacturing facilities are then extracted. So we need to start asking ourselves, where's this all going? So we want to participate in the technology. We need to recognize its threats and its benefits. How do we engage? And actually, South Africa is a very good example of what has happened. The CSIR has worked with a company called Aerosud to design and develop what is currently labeled as the world's largest 3D printer. And what they've done is they've developed a process to turn titanium into a powder that's then used by this printer to create aircraft parts. So it's strong and it's light and it's everything you need it to be. It's manufactured right here. We're using one of our own minerals that we previously could only export. We could not benefit from it prior to export. So that illustrates how you start engaging with the technology at other levels of the value chain as well. To try and counteract other potential economic disadvantages, but that means we need to be able to enable this technology. Here is the greatest drawback, possibly, of this technology, and that is the enforcement of rights when it comes to almost absolutely uncontrolled infringement of IP rights. How do we facilitate enforcement, and do we increase enforcement capabilities? Because what comes with that is an increased exposure to liability. So where you have service providers or manufacturers that want to enable this technology, that want to develop this technology, that want to connect consumers to this technology, they now sit with a situation where they have an increased exposure to liability for contributory infringement, for instance. And this is where the balance comes in. How do we balance it out? How do we make sure that we try and find the sweet spot in the middle where we know that we can freely participate in this technology, we can develop and benefit greatly on a socioeconomic level, but at the same time not deter investment because companies coming in and wanting to engage with the technology faces infringement lawsuits, or rights holders feel that their rights are not sufficiently protected because we freely allow this type of technology. How do we find that balance? I don't know, but a couple of questions that have come to mind is we need to look at all of the steps involved in the process. From the article, the 3D article in the beginning, or the design in the beginning, to the article at the end. What in that process is protected currently? What should be protected? Should we lessen protection? Should we heighten protection? What about the works or the articles or the objects that are involved or that are created during this process? Thinking about the slicing process where you're adding instructions onto the CAD file to direct a computer to do something. Is that a computer program for purposes of copyright law, for instance? Should it be something else? Should it even be recognized at all? Because you can just think that in very complicated parts or very complicated objects, that is where a lot of skill and knowledge is going to lie in future, is how to direct that printer, at what speed and temperature and what material and where. So it could become a great value add that may need protection. What about the authors or the creators or the inventors? Are they recognized? Should they be recognized? If we're talking about the fourth industrial revolution and the blurring of the lines between physical and digital, or the coming in of AI, let's take a motor vehicle manufacturing line. Let's say AI has been implemented there, and the AI technology can pick up in the manufacturing that there's a part that can be enhanced, that needs to be adjusted, that can be manufactured differently, a part that is being 3D printed. It picks it up, it sends instructions to the computer that amends the design, that then sends it to the printer that prints the part. No human involvement. What do we do with that? Should we be acknowledging or recognizing someone there? And then again, what about the infringements? How do we control the infringements? How do we deal with the infringements? Should we start looking at our exceptions? There's a big debate going on in Australia at the moment that the legislation is just too rigid to allow this technology to take the economy where it needs to go, and they are currently looking at introducing fair use exceptions. Same debate we're having here for a different reason, but it becomes relevant in that area too. And then what about legislative amendments? Do we need any, or should we be perhaps looking at some specific legislation to deal with this issue? And specifically, again, with reference to the infringements, should we be looking at stuff like, in Australia, for instance, they've got site blocking legislation, America too, or safe harbor legislation, the technical protection measures, all of that come into play. We need to consider either way to plug it in or how to deal with it separately. That's the conundrum. Thank you.
Wonderful.
Thanks.
Thank you. We ran over slightly, but that was just too good to stop.
That was on purpose,
thank you
sorry.
very much. No, that was absolutely wonderful. I mean, it kind of reminds me of when we moved over from CDs to online music and then obviously streaming, and everyone was struggling to sort of manage this and wrap their minds around it, and now that's kind of been largely settled, and I suspect over time so will this. But it caused great upheaval, and I'm sure this will, especially from a rights holder point of view, if you've got registered designs on all these products that are just going to be copied willy-nilly. It's very interesting issues. Again, more questions than answers, but that's the nature of the work we do. Well done.
Can I just mention one thing on that point, Johnny, that I found very interesting, especially when it comes to the big role players, the big guys in the manufacturing industries, is that they appear to be less, at this point in time at least, less inclined to want to tackle too much of the infringement issue. BMW right now, go onto its website, .com. You will find design files there that you can download and print yourself of the BMW logo. It's there. So here it is. Go print yourself a keyring if you're driving the vehicle. Mattel, the toy manufacturer, has released a product. It's a toy 3D printer kids can use. They've got the app on the phone and they print their own toys. So it's strange. They're more engaging with this technology than they're fighting against it, which is maybe the right way to go.
Yeah, without a doubt, I think that is the trend that's been going. I saw a question from Tinus talking about possibly, having at those depositories where those files are available, having some sort of paid access. And again, that would be in a way similar to some of the music models that are being used. Mm-hmm. So thank you for that comment. Yeah, so Karen.
If I sell a file directly to you, then we can talk money. And if I upload it to a repository and then there's some rules or whatever, and then anybody getting a file from there can get it at a fee, unless there's many other free versions on the same thing. So I think there will be some ability or place to get money out of that, so that
the licensing of sorts.
You'll get paid for your copyrighted thing. Because if you just rely on the user, you are dead. We saw in the agricultural environment, people were supposed to pay for what do you call it? Plant breeders.
Yeah.
You paid for the number of plants you propagated from vines. But then the people started lying, so they ended up having huge crops from only the 5 trees they declared, which is impossible. So they just outsmarted them and said, okay, never mind if you have 5 trees or 5,000 trees, getting one bunch of grapes from one vine or 1,000 or the other way around. We'll charge you based on your output, of the number of boxes you sell, and they schemed that off as a marketing step. So you check which section or which part of this whole transaction or deal flow is traceable or able to monitor and then skim off there.
Awesome. Thanks.
Yeah.
Thanks.
It's also where the technological protection measures come in, because this debate's ongoing in the US at the moment to what extent it should be allowed or not, and because Disney has just filed a patent that would make it impossible to scan the objects. So, you know, their little figurines, if they put them out into the market, they will not be scannable, because that's where it starts. It starts with the scanning process that then goes into the CAD file that gets printed.
Thank you. I mean, there's a wonderful comment or query about whether one can print medicine for people,
Yes.
poor people. Whoever asked that was a wonderful question. You know, and that
No, you
raises
can.
all sorts of
You can.
debates.
And you know what they're doing? They're printing your daily dose for you. So instead of you taking 5 pills, you can print one single tablet that will have everything that you need for today in it, and you take one tablet and off you go. Yeah.
Okay, one quick last one, sorry.
Yeah, just a comment on what you just said is they already printed the cartilage bone for ears, future replacement.
Cranium, skin.
Jawbones,
Yeah.
titanium jawbones, locally.
Yeah.
Fascinating. All right, thanks. Thank you very much again. Lovely.
you.
Thank you, Werina.